Welcome to microprocessor and microcontrollers. In this lecture, I am going to explain about serial communication basics. So, this is the syllabus of Unit 5 in microprocessor and microcontrollers. So, coming to the introduction, what is communication? It is way of exchanging data between two or more systems or devices. For example, like this. This is a sender receiver. Message is transferred between medium. Message will be exchange, right? Here we have to observe that to exchange the message, these are standards, that's communication protocols or the standards that contains data exchange rules and formats between systems here, right? Yes. Within a microcomputer system, the data transfer is parallel because it is faster method. But transferring the data over long distances, the parallel data transmission requires too many wires and is complicated and expensive. And one more, if there is an error in parallel communication in over long distance, then it is again we have to send the data. It will take more time, and it is expensive also because n bits. If you want to transfer n bits, it requires n wires. So therefore, the data is to send for long distances is converted into serial form so that it can be sent on a single wire, because by using single wire we can send the data serial bit by bit, so cost is less. That's hardware requirements are less in that case, right? At the destination, the received signal data is converted into parallel form so that it can be easily transferred onto the microcomputer systems. For example, this is coming to parallel data transmission, right? Sending multiple bits simultaneous like this. 8 bits, 8 wires are required, right? But serial communication, we can send one bit at a time, only one wire is required. So the difference between serial and parallel: number of bits transmitted at one clock, here 1, here n bits. Here number of lines required or wires required for n bits, here 1, here n lines. Speed of data transfer, serial slow, parallel fast. Cost of transmission low, here high. Applications: long distance communication and short distance communication. So coming to serial communication, the transmission modes. There are 3 types of transmission modes: simplex, half duplex, full duplex. In half duplex communication, the data will be transferred. Yes, data will be transferred between the transmitter and receiver only. The transmitter will send data to receiver. The data will transfer in only one direction. Half duplex. In half duplex mode, each station can be both transmit, receive, but not at the same time, right? You can see here the transmitter can send the data to receiver, it will receive, or it can transmit the data, it can receive any one, right? Example, Vakitex. Full duplex communication, data transfer will take place in both directions, the data will flow in both directions, so it requires 2 wires. Example, telephone networks. So there are in serial communication, to transfer data there are modes: synchronous mode, asynchronous mode. In the synchronous mode we are going to use clock, and in asynchronous mode there is no clock between the transmitter and receiver, separate clock. Here you can see common clock is used in both transmitter and receiver. Here separate clocks. Here sync pulses are required to separate data. Here start and stop bits are required to separate data, and the characters transmitted sending the sync pulse. Here also start and stop bits. So this is high speed data transmission, low speed data transmission, used between CPU and other devices. Here used exchange data with other equipment such as PC. Example is VRT, IRDA, and for synchronous SPI and I2C protocols. Coming to UART, asynchronous full duplex communication, no clocks is transmitted along with the data, use only two signals for communication, TX and DX. Coming to SPI, synchronous full duplex, clock signal is transmitted along with the data, so uses 4 wires: master output, slave in, master input, slave out, slave clock, slave select, and integrated circuitized to CI2C simplex half duplex. Clock is transmitted along with the data, uses 2 bidirectional lines for communication, serial data and serial clock. So coming to applications of serial port, so the serial communication ports are used for sending and receiving data from other devices and modules connected to the microcontrollers. So the UART is used to exchange data with other external equipment such as PC. The SPI and I2C have similar applications used to transfer data between CPU and other devices on same PCB board, as the same power supply and clock are used. SPI and I2C are often used to communicate with ports expanders to increase the effectiveness of pins for digital IOs, and ADC and DAC sensors with digital outputs such as thermometers, external memory, real-time clocks, interfacing of other processors. So this is about the basics of serial communication.